Welcome back. I hope that you were able to get through the percent problems and also the practice exam that's in the CEI workbook, and that is on pages 23 to 27. So you should have gotten page 18, 19, 20, and 21. And then the practice test is on page 23 to 27. So that's something you want to work on this week. But for now, we're going to do a short review of integers. Hopefully, you've also been able to access in D2L the integer information. There's no need to print that off. That's going to be a lot of pages. But you can look through that information on integers, that presentation, and just sort of answer the questions as you go. They're very, very short compared to some of the things we've been doing. And check your answers and just make sure that you understand how to add, subtract, multiply, and divide integers. And we're going to work on that in problems that are more complex together here. So you'll want to, if you haven't had a chance to go to D2L and look at the integer information that is there under this week, it's dated by the week. It'll have the week of 4-5 to 4-8. Then you certainly want to do that first before watching this video. Hopefully you're watching this video using your headphones in D2L, but if not, we'll just keep working on that and hope for the best. So what I'd like to do is just review a couple of the shorter just integer rules, and then we'll look at some problems together that are a little bit longer involving order of operations with integers. So I'm going to minimize this, make this bigger. Okay. And where we'll be starting is in the CEI workbook. Let me get that page for you. Okay. Now, the things we're going to do first really aren't in the workbook. They're just a little review after you've gone through that other packet on D2L. Okay. But here we're looking at pages 43, 44 in your workbook, 43 and 44. Okay. So, we are going to finish up this section by doing pages 42, 43, 44, and 45. But for now, it's just 43 and 44 that we're looking at. Okay. Well, I think this is actually page 44 and 45 that we're looking at. Okay, so let's see. This is a little bit much to start with. Let's just start with some examples. Okay, so example number 1, I'm going to say -6 plus 4. Just as a reminder that when we combine, I'll tend to not say add and subtract as much as I say combine for both of those, because that gets confusing. If I tell you to add but you're really subtracting, if I tell you to subtract but you're really adding, that happens when we work with integers. Remember, integers are whole numbers and they're opposites. So the opposite of 4 is -4. The opposite of -6 is +6. When I want to put these together, I basically look at, this is -6, this is +4. If the signs are opposite, one's negative and one's positive, what I really do is subtract the numbers, and then I keep the sign of the number that has the larger absolute value. So 6 is larger than 4. -6 is not larger than 4, but 6, the absolute, let's just kind of review that. The absolute value of -6 is 6. Okay. The absolute value of +4 is 4. So whichever one has the larger absolute value, that's the sign we keep. So that means my answer is going to be negative. Okay. So this is going to be, if I subtract 6 and 4, I get 2, and then I keep the negative. So you're going to have to kind of get used to that. Sometimes it helps to draw out chips or something like that, or have pieces of paper until you kind of get used to it. We'll have one color for negative. Let's say that that's just these open circles. So I have 6 of these, and then a different color for positive. So I'm going to just do a shaded circle. So I have 4 of those. And I want to put these all together. But the rule is that opposite things cancel each other out. So this will be -1 and +1. Those add out to 0. So every time I have a set like that, they're going to wipe each other out to 0. And then whatever's left, it shows you the sign because there were more of these chips than this kind. So there are 2 of them, and these open circles represented negative chips, so -2. Okay, let's try another one. Let's do, let's see, 5 plus -3. 5 plus -3. So if you wanted to do it with a chip model, I could do 5 of the shaded chips, and then 3 of the open circle ones. Okay, so 5 of these that are, let's see, wait a minute, is that right? Yeah. 5 of the shaded, okay, and 3 of the open circle. And now every time I have 1 of each, they wipe each other out to 0, and I'm left with 2 of something, and the shaded ones represent the positive numbers. So +2. And again, 5 plus -3, when you have opposite signs, you subtract the 2 numbers and keep the sign, the number with the larger absolute value. So 5 is larger than 3, so that'd be +2. If I want to add 2 negative numbers, like -4 plus -1, okay, that would be 1, 2, 3, 4, and then 1. Well, all these chips are the same, okay, so there's nothing to cancel out. I just put them all together. 1, 2, 3, 4, 5. There's 5 chips. So when things have the same sign on them, you add 4 and 1 and just keep the sign. Okay, things that are alike, we just keep them. Very much like if that had been regular 4 plus 1, it would have been +5. Okay, and let's do a couple of multiplication and division. When I multiply a negative times a positive, when I multiply a negative times a positive, then that's negative. When I multiply a positive times a negative, same thing, because multiplication is commutative, you can do it in either order. What if I multiply 2 negatives? -2 times -3. Negative times negative is positive. 2 negatives makes a positive when you are doing this type of multiplication. Okay, multiplication, you basically just count the negative signs. If there's an odd number of negative signs in multiplication, like here I had 1, here I had 1, if there's an odd number of negative signs, the answer is negative. If there's an even number of negative signs, like here I had 2, the answer is positive. Now that works with multiplication or division. So if I had, let's say, -10 over -2. Okay, negative divided by negative, there's 2 negatives, that makes a +5. Whereas if I had -10 over +2, that's only 1 negative sign. If there's an odd number of negative signs, answer's negative when you're talking about multiplication or division. So 2 goes into 10 5 times, but there's only 1 negative sign, so that stays negative. Okay, so that's just a really brief review of those sign rules that we looked at in the other packet on D2L. So let's do just a few of these problems that are from your packet. So I'm going to just look at this page. This is going to be the challenging page, the one that starts with number 5. Okay, I think that's 45 for you. Your page numbers are slightly different than mine. And again, I have these boxes for whatever reason. You should have multiplication signs. get that in a little closer. Let's just do maybe about 4 of these, just to kind of get the idea. We're back to order of operations, which we haven't done in it's been a couple of weeks since we did order of operations. How about number 6? Now that box right there should be a multiplication symbol. Get that a little bit more zoomed in. Sometimes it makes it fuzzy. Sorry about that. There we go. That's better. Okay. So let's try this number 6. This should be multiplication right here. Remember, order of operations. Parentheses first. Please excuse my dear Aunt Sally. Resolve what's in parentheses first, then exponents, then multiplication and division, then addition and subtraction. So I'm just going to go ahead and make this down to one number. Now, what's 7 minus 9? Okay, that's just the same thing as saying 7 plus negative 9. I have one of each sign, so I'm going to subtract them and keep the sign of the larger number. If you wanted to think of it on a number line, it's 7, take away 9. So if I start here at 0, 1, 2, 3, 4, 5, 6, 7. So I have 7, but I'm going to take 9 away. That puts me, that's on past 0. How far is it past 0? 2 slots. Okay, 7 take away 9 is negative 2 squared. So we haven't seen anything where we have to raise a negative number to a power. And that's tricky. We'll talk more about that. We'll talk about that again. You won't have to do that very much here. So I'm not going to talk too much about it. But a negative number raised to a power, just go off to the side. That means negative 2 times negative 2. That's what that means. And negative times negative is positive 4. So this is divided by 4. And now let's just work that out. Okay. Multiplication and division is left to right. So it's 13 plus 20 divided by 4. Okay, and that's going to be, I'm just going to jump down here. That's going to be 13 plus 20 divided by 4 is 5. That's 18. Okay, so just watch those negatives. Raising a negative number to a power is a little bit tricky. So just be careful about that. Like I said, you won't really want to do it very much right now, and we'll go over that a lot more when you do have to do it. Okay, so let's jump on down to, let's do one with, let's see if any of these are going to have integers in them. What about number 12? That has all of it. That's fractions, that has a negative number raised to a power, that has an absolute value over here, so there's a lot going on. And I think this is supposed to also be multiplication. Okay, so I have addition, I have something raised to an exponent, and I have an absolute value. Well, in the order of operations, you can think of absolute value as really like parentheses in a sense. Okay, so you want to go ahead and resolve that. So this 1/8 plus, now negative 3/4, there's nothing to do inside those parentheses. That's already just one number. But I do need to raise it to the second power. So I'm just going to write that out twice so you can see that a little bit better. Negative 3/4 to the second power is negative 3/4 times negative 3/4. Now over here, what's the absolute value of negative 2/3? Remember, the absolute value tells us how far something is from 0. The negative just tells us which direction it is. So negative 2/3, how far away from that is 0? Well, 2/3. Okay, so the absolute value of negative 2/3 is 2/3. Now I have addition, we'll do that last, and then this is multiplication and multiplication. So we'll just go left to right. So that's 1/8. Negative times negative is positive. And remember, when you multiply fractions, top times top, so 3 times 3 is 9, bottom times bottom, 16, times 2/3. So I have to deal with this multiplication. That's 1/8 plus top times top, 9 times 2 is 18, bottom times bottom, 16 times 3 is 48. Okay, almost done here. I'm just going to keep going on down. So I have 1/8 plus, now you might go ahead and reduce that fraction if you wanted to where your numbers aren't so large, or you can just work with it like it is. I'm just going to recopy it so you can see it a little better. It's 18 over 48. I don't know if you can see that any better or not. Now, common denominator, okay, 8 goes into 48. So why not just use 48 as a common denominator? Okay, and 6 times 8 is 48. So 6 times 1 up here is 6 plus 18. Now I have a common denominator, so I can just add the tops. 6 plus 18 is 24 over 48. Now 24 goes into both of those. I mean, several things go into both of those. 2 does, and 4 does, and 6 does. But 24 is the largest thing that goes into both of them. So that should reduce to 1/2. Okay. And let's just do a couple more of those. So about number 13. This one has a lot of negative signs and a lot of absolute, and it has its absolute value. So you're going to have to be careful here. So there's no reason for these parentheses to be here. This is not being raised to a power or anything like that. So I can just go ahead and get rid of those front parentheses. -6, and I'm going to bring this down, minus. Now let's find the absolute value of -6. How far is -6 away from 0? It is 6 units away from 0. So the absolute value for -6 is 6. Okay, I'm just going to write that up here. The absolute value of -6 is 6. Okay, why? Well, we can draw a number line if you want to. Here's 0, 3, 4, 5, 6. Here's -6. How far is that? Absolute value is a distance. How far away is -6 from 0? Count the little tick marks. It's 6 units away from 0. It's just this direction. Okay? It's like saying that you backed out of your driveway. Well, you still drove. Let's say your driveway is 100 feet long. You still went 100 feet. It's just that you went in reverse. Okay? So when you're talking about what distance did I travel, well, you still traveled 100 feet. Just backwards. Okay, so absolute value is the same idea. It's a distance. How far is this number from 0? 6 units. It's just over here instead of up here. So the absolute value is 6. Now let's put these together. -6 minus 6. Remember, when I add or subtract things with the same sign, I add the two numbers and then just keep the sign. So this is the same thing if you'd rather write it like this. -6 plus -6. Some people prefer it to look like that. That's fine. Okay. Either way, it's -12. You put the 6's together, 6 and 6, and then you keep the sign. Okay. So let's see. Let's do this last one down here. Let's do number 15. And let's just work the top separately from the bottom. Okay, we saw this when we did these before with order of operations. It's just easier to work the numerator to one number and then work the denominator and then divide. Okay, so the numerator is going to be -8 minus, we have to resolve this exponent first, -4 squared. Notice that the negative is raised to the second power. So that is -4 times -4. You write it out twice. Negative times negative is +16. So that's what comes down here. So I just copy down the negative 8 and the minus, and then I just replace that with 16. Okay, now we can go on across here and see what that's going to be. What's negative 8 minus 16? They're both negative. The 8's negative, the 16's negative, and I'm adding and subtracting, so I just need to combine these. Because they both have the same negative sign, I add the 8 and 16 and keep the sign negative. So that's my numerator. Now let's look at the bottom. That's negative 6. What do I do with this double negative right here? Okay, minus negative 3. Remember, that's going to be plus. Okay, it's like saying the opposite of 3. Okay, that's negative 6 plus 3, which is they have opposite signs. So I subtract the numbers and keep the sign of the larger number. And then 3 goes into 24 8 times. I have negative divided by negative. 2 negatives in division is positive. So that's just positive 8. Now again, I'm kind of assuming that you've looked at that other packet, you've practiced, some of the simple ways to combine sign numbers before you're trying these problems. Okay, these are a lot more challenging. But realistically, if you haven't ever worked with sign rules before, positive, negative numbers, it's going to take you a while. And you'll get that practice, so don't worry about that. You'll get lots of practice. We'll do that again in the class that you take over the summer, and so you'll get a lot of practice with these sign numbers. So this is just a little bit. I know that it's it's supposed to be a review, but realistically, a lot of people haven't worked with sign numbers yet, so this may be a sticking point for you, and we'll have to come back to it. Okay, and we will. But for now, go ahead and do in the CEI workbook, pages 42 to 45. And some of those, if you have trouble with it, just put a star beside it. We'll see if we can't come back to that. So the CEI workbook, page 42 to 45. Okay, and then, like I said, hopefully we'll be able to add more to D2L and then get everybody working in my math lab and things that may be a little bit smoother for you.